In the past decade, the population of Qatar has increased significantly. In the years leading up to 2011 and 2012, there was a 7.5% population growth rate. Presently, there are no signs of this population growth decreasing since Qatar received the 2022 FIFA World Cup, and the influx of people in Qatar has increased even further. This dramatic growth of the population has increased water consumption. An article published in Gulf Times in 2016 states that there was a 70% rise in Qatar's water utilization leading up to 2013. This inherently goes against Qatar's 2030 vision of a sustainable future, and this project proposes a solution to decrease water consumption.
The first part is for the manual experiment and was watered daily using the glass beaker to the right. The soil moisture sensors are placed next to the roots of both plants. For the automated system, a relay was used as a switch controlling the solenoid valve, which was in turn connected to the virtual bench acting as its power source. When the soil moisture value falls below the minimum threshold of the optimal range for the soil, the solenoid valve opens, allowing the water to flow through the plastic tube into the soil. The valve remains closed if the soil moisture value is above the minimum threshold.
To calibrate the IR sensor, a circular piece of foam was placed in the water tank, which initially contained 60 ml of water. The sensor was placed in the center of the tank to ensure that the infrared rays do not bounce off the walls of the container. Once the LabVIEW code was set up, the sensor recorded the voltage corresponding to the amount of water. With each reading, 20 ml of water was added. 10 voltage values for each data point were recorded. The average of those values was then calculated. This is a graph of the voltage against volume. It was observed that as volume increases, the distance between the sensor and the foam decreases, thus increasing the voltage. Next, linear regression was carried out. The relationship that was established between the voltage from the IR sensor and the volume of water in the tank is shown in this graph. The next graph includes error bars, which showed the 95% confidence interval for each data point. The experiment has been carried out for 3 weeks. The first week we spent testing the functionality and parameters of our experimental sensors. On the 5th day, we encountered a problem. We observed that after a period of time, all sensors went to zero, causing the solenoid valve to open and continuously pump out water. To save the plants, we added a safety measure which stopped the VI when values went to zero, and fixed the error by restarting the system. Once the experiment ran without any problems for 2 more days, we replaced the test pans with 2 new identical plants and repeated the experiment. This graph shows the change in moisture level percentage over time in 1 day. As you can see, both the automated system and the manual system were above the threshold value. Similar results were obtained on the other days. This graph shows the volume of water added on each day for the 2 plants. The orange bar represents the manual system, while the blue bar represents the automated system. Current data shows that approximately 30 times more water was added in the manual plant as compared to the automated. This shows that our hypothesis was true, as more water was used in the manual system than our automated system, while the moisture levels for both plants were within the optimal range.
If this project was to be performed in future, we would recommend this experiment to be performed outside so the plants can be exposed to climatic conditions. Also, the scope of the experiment can be increased by measuring factors such as pH value and soil mineral content instead of only measuring the soil moisture content.